Far from the warmth of the inner solar system, beyond the asteroid belt, beyond the reach of anything familiar, there is a giant. A planet so massive that it contains more matter than every other planet combined. A world of swirling clouds and ancient storms, wrapped in radiation belts that would kill anything alive within minutes. This is Jupiter, and it is not alone. Orbiting this enormous world is a collection of moons so strange, so varied, and so full of surprises that they feel less like a set of satellites and more like a miniature solar system of their own. Volcanic worlds where molten rock erupts hundreds of kilometers into space. Frozen worlds hiding vast oceans beneath shells of ice. Ancient, cratered worlds that have remained almost unchanged for billions of years. Tonight, we're going to visit 4 of them. The 4 largest moons of Jupiter, discovered by Galileo in 1610, and still among the most fascinating places in the cosmos more than 4 centuries later. Take a deep breath. Let everything else fall away. And let us drift out to Jupiter together. Let's begin with the most violent place in the solar system. A world that makes Earth's most active volcanoes look gentle by comparison. Io is roughly the same size as our moon, but that is where the similarities end. While our moon is cold, dead, and unchanging, Io is alive with geological fury. Its surface is covered with hundreds of active volcanoes. Lava flows stretch for hundreds of kilometers across plains of sulfur and sulfur dioxide. Volcanic plumes erupt with such force that they shoot material 300 kilometers above the surface, high enough to be visible from orbit. The colors of Io are unlike anything else in the solar system. Yellows, oranges, reds, blacks, and whites paint the surface in a chaotic patchwork. These colors come from different forms of sulfur and sulfur compounds, heated to different temperatures by the relentless volcanic activity beneath. But why is Io so volcanic? The answer is Jupiter. Io orbits very close to Jupiter, and Jupiter is enormous. The gravitational pull of the giant planet, combined with the gravitational influence of the other large moons, creates a phenomenon called tidal heating. As Io orbits Jupiter, the gravitational forces squeeze and stretch the moon's interior. This constant flexing generates enormous amounts of friction and heat deep within Io, keeping its interior molten. Think of it like repeatedly bending a paperclip back and forth. The metal gets hot. The same principle applies to Io, except on a planetary scale. The entire interior of the moon is being kneaded like dough by Jupiter's gravity, and the heat has nowhere to go except up through hundreds of volcanoes that the surface. Io's surface is constantly being reshaped. Old lava flows are buried by new ones. Craters are filled in almost as quickly as they form. The surface of Io is one of the youngest in the solar system, not because the moon is young, but because it is constantly being rebuilt from the inside out. No spacecraft has ever landed on Io. The radiation environment near Jupiter is intense, and the volcanic surface would be a nightmare for any lander. But the images we have from the Voyager and Galileo missions show a world of raw, untamed geological power. A world where the ground beneath your feet could erupt at any moment. A world shaped not by wind or water, but by the relentless grip of the largest planet in the solar system. Now let us move outward from Jupiter past Io to a world that could not be more different. If Io is fire, Europa is ice. Its surface is one of the smoothest in the solar system, a shell of water ice crisscrossed with long, reddish-brown cracks that stretch for thousands of kilometers. There are very few impact craters, which tells us something remarkable. The surface is young. Something is erasing the craters, smoothing the surface, renewing it over time. That something is an ocean. Beneath Europa's icy shell, estimated to be 10 to 30 kilometers thick, lies a global ocean of liquid water. Not a small underground lake. A world-spanning ocean that may contain twice as much water as all the oceans on Earth combined. This ocean exists because of the same tidal heating that powers Io's volcanoes. Europa also orbits close to Jupiter, and the gravitational flexing warms its interior enough to keep water liquid beneath the ice. The heat is not as intense as on Io, so instead of volcanoes, Europa has a hidden sea. The cracks on Europa's surface are thought to be caused by the constant flexing of the ice shell as Jupiter's gravity pulls and stretches it. The ice cracks open, dark material from below wells up and freezes, and the cracks slowly heal. It is a surface in constant, slow motion, driven by the tides of a distant giant. But the truly extraordinary thing about Europa is not the ice or the cracks. It is what might live in that ocean. On Earth, everywhere we find liquid water, we find life. From the deepest ocean trenches to the hottest volcanic springs, from the driest deserts to the coldest Antarctic lakes, if there is water, there is life. And Europa has an enormous amount of water. If that ocean has hydrothermal vents on its floor, similar to the ones found deep in Earth's oceans, then it has all the ingredients that life seems to need. Liquid water, chemical energy, minerals, warmth, and billions of years of stable conditions. No one knows if life exists on Europa. It is one of the greatest unanswered questions in all of science. But the possibility is real enough that NASA is sending a dedicated mission to find out. The Europa Clipper spacecraft, launched in 2024, will perform dozens of close flybys of Europa, studying the ice shell, measuring the depth of the ocean, and searching for signs of the chemistry that could support living things. If life is found on Europa, it would be one of the most profound discoveries in human history. It would mean that life is not unique to Earth. It would mean that the universe is capable of producing living things independently, in completely separate environments. It would change everything we think we know about our place in the cosmos. And it all comes down to a frozen moon orbiting a gas giant 780 million kilometers from the Sun. Let us continue our journey outward to the largest moon in the entire solar system. Ganymede. Ganymede is bigger than the planet Mercury. If it orbited the Sun instead of Jupiter, it would easily be classified as a planet in its own right. It is a world of contrasts, with two distinctly different types of terrain covering its surface. About 1/3 of Ganymede's surface is covered in dark, heavily cratered terrain. This is ancient ground billions of years old, scarred by countless impacts from the early days of the solar system. It is a record of violence, a surface that has been pounded by debris for eons. The remaining 2/3 is covered in lighter, grooved terrain. Long parallel ridges and valleys stretch across the surface, sometimes for thousands of kilometers. This grooved terrain is younger than the dark terrain, and it was likely formed by tectonic activity, the stretching and cracking of the surface driven by forces within the moon. But Ganymede's most remarkable feature is invisible to the eye. It has its own magnetic field. It is the only moon in the solar system known to generate a magnetic field from its interior. This magnetic field is embedded within Jupiter's much larger magnetic field, creating a complex interaction that produces beautiful auroras near Ganymede's poles. The existence of a magnetic field tells us something important about Ganymede's interior. To generate a magnetic field, a world needs a liquid, electrically conducting core. Ganymede likely has a core of liquid iron, similar to Earth's core, churning and flowing deep beneath its icy surface. And like Europa, Ganymede may also have a subsurface ocean. Observations from the Hubble Space Telescope, studying the behavior of Ganymede's auroras, have provided strong evidence for a salty ocean buried deep beneath the ice, perhaps 150 kilometers below the surface. This ocean would be sandwiched between layers of ice, with a layer of high-pressure ice below it and the outer ice shell above. Ganymede is a world of layers. An icy surface, ancient craters and young grooves, a possible ocean, a liquid iron core, a magnetic field, auroras. It is one of the most complex and fascinating worlds in the solar system, and we have barely begun to explore it. The European Space Agency's JUICE mission, which stands for Jupiter Icy Moons Explorer, is currently on its way to the Jupiter system and will eventually enter orbit around Ganymede. It will be the first spacecraft to orbit a moon other than our own. The data it sends back will transform our understanding of this extraordinary world. Our final destination tonight is the outermost of Jupiter's 4 great moons. Callisto. If Io is fire, Europa is mystery, and Ganymede is complexity, then Callisto is memory. It is a world that remembers. Callisto's surface is the most heavily cratered in the entire solar system. Almost every square kilometer is marked by an impact crater, from tiny pits to enormous multi-ring basins hundreds of kilometers across. The largest of these, Valhalla, has a bright central region surrounded by concentric rings that extend outward for nearly 2,000 kilometers, like ripples frozen in ice. The reason Callisto is so heavily cratered is simple. Nothing has ever erased those craters. Unlike Io, which is constantly resurfaced by volcanoes, or Europa, which is smoothed by its shifting ice shell, or Ganymede, which has been partially resurfaced by tectonic activity, Callisto has remained geologically dead for most of its history. Its surface is a fossil record of the bombardment that shaped the early solar system, preserved almost perfectly for over 4 billion years. Callisto orbits far enough from Jupiter that tidal heating has little effect on it. Without that internal heat source, the moon's interior has remained cold and relatively inactive. It is the quiet sibling, the one that stayed still while the others changed and evolved. But even Callisto has its secrets. Measurements from a Galileo spacecraft suggest that Callisto, too, may have a subsurface ocean buried deep beneath its ancient, cratered surface. If this is true, it would mean that 3 of Jupiter's 4 large moons have hidden oceans. 3 separate worlds, each with vast reservoirs of liquid water, all orbiting the same planet. The idea that a world as old and seemingly dead as Callisto could harbor a liquid ocean is a powerful reminder that appearances can be deceiving. The most ancient, most battered surface in the solar system may be hiding one of its most intriguing secrets. Callisto also has a unique property that makes it interesting for future human exploration. It orbits far enough from Jupiter that the radiation levels on its surface are much lower than those on the inner moons. A base on Callisto could serve as a staging point for exploring the rest of the Jupiter system, a safe harbor in an otherwise hostile environment. Someday, humans may stand on the cratered surface of Callisto and look up at Jupiter hanging in the sky, enormous and striped, with its great red spots staring back at them like an ancient eye. And from that vantage point, they may send probes to Europa to drill through the ice and explore the ocean beneath. That day may be centuries away, but the first steps toward it are being taken now. There's a question that hangs over everything we have discussed tonight. A question that is simple to ask, but extraordinary in its implications. What would it be like to actually stand on one of these moons? Let's imagine you're standing on the surface of Europa. The ground beneath your feet is water ice, hard as granite in the extreme cold. The temperature is about minus 160 degrees. Your breath, if you could breathe the thin, almost non-existent atmosphere, would freeze instantly into tiny crystals of ice. You look down. The ice beneath you is not smooth. Up close, you can see that it is fractured and jumbled, with blocks of ice tilted at odd angles, like a frozen version of pack ice in the Arctic. In some places, the surface is stained reddish-brown by salts and other minerals that have seeped up from below. These stains may be clues to the composition of the ocean beneath your feet. And what an ocean it is! Somewhere below you, perhaps 10 kilometers down, perhaps 30, there is liquid water. An ocean that wraps around the entire moon. An ocean that has existed for billions of years, warmed from below by the heat of tidal flexing, insulated from above by a shell of ice that has never melted. If you could drill through that ice, if you could lower a camera into the darkness beneath, what would you see? Black water at first. Complete darkness. No sunlight has ever reached this ocean. But as your camera descends, you might begin to see a faint glow. Even here, in the most ancient and battered landscape in the solar system, the possibility of a hidden ocean remains. If that does not fill you with wonder, nothing will.